Today we are walking through the paper titled LLM Reasoning is Latent, Not the Chain of Thought.
What is the main claim we should keep in mind first?
The paper argues that reasoning in large language models should be studied mainly as a hidden state trajectory, not as the visible chain of thought text. The visible words can help, but the paper treats them as only one interface to a deeper process.
When you say hidden state trajectory, do you mean the model is reasoning somewhere other than the words it prints?
Yes, the paper separates three objects. S is the surface chain of thought, meaning the explicit intermediate text. Z is the latent trajectory, meaning the hidden state path that carries task commitments. B is generic serial compute, meaning extra budget for search, sampling, looping, or verification.
So the prior work problem is not that chain of thought never helps, right?
Right. The paper says chain of thought often helps, and extra compute often helps. The problem is that many studies move S, C, and B together. If accuracy improves while the visible trace gets longer, the hidden states change, and the compute budget also increases. That result cannot tell us which object actually caused the improvement.
What are the three explanations the paper compares?
Hone says reasoning is primarily mediated by latent trajectories. H2 says reasoning is primarily mediated by explicit chain of thought. H0 says most apparent reasoning gains are just generic serial compute. The paper's position is that current evidence most strongly supports Hone as the default working hypothesis, while H2 and H0 still explain important boundary cases.
What is the fairest case for the visible chain of thought view?
The strongest H2 case comes from tasks where the visible trace is made constitutive. For example, structured retrieval plans, tool calls, check traces, or deterministic solvers can make the external steps part of the actual computation. In that setting, the trace is not just a story after the answer.
And what limits that view for ordinary chain of thought?
Ordinary chain of thought is often incomplete, selective, or unfaithful. It can improve answers without proving that the visible content is the privileged cause. The paper says H2 needs stronger evidence. Change the semantic content of the trace while holding compute fixed, and show that the final answer follows that trace.
What about the compute-only explanation?
H0 has real force because self-consistency, search, verification, and test time scaling can all improve reasoning by spending more serial budget. The paper's objection is that budget alone is too coarse. It does not explain why specific hidden states can predict correctness early, or why steering particular internal features can change reasoning behavior.
Then what does the paper propose as a better test?
The proposed design asks experiments to isolate the manipulated object, match generic serial compute wherever possible, and state in advance which outcome would support one hypothesis while counting against a rival. That is the methodological center of the paper.
What do the experimental arms look like in that design?
The paper uses 6 reusable arms. There is a targeted surface manipulation and a compute-matched surface control. There is a targeted latent intervention and a matched latent sham. Then there is a compute-only expansion, plus the direct answer baseline. This separates a surface contrast, a latent contrast, and a compute-only contrast without pretending they are the same question.
How does the paper keep the budget comparison fair?
It introduces an audited equivalent budget. The equation adds weighted counts for decoding, key-value cache operations, hooks, verifier calls, tool calls. The point is not that this ledger is perfect. The point is that surface latent and compute policy should not win just because one secretly spent more inference budget.
What tasks does the paper use to make those contrasts concrete?
It uses a controlled tier and a naturalistic tier. The controlled tier renders template families under ordinary, constitutive, search dominant, and mixed regimes. The naturalistic tier transports the same logic to GSM8K Platinum, Hotbot QA Distractor, a M80H subset, and Human Evil.
What did the frontier results show?
In ordinary regimes, the latent family wins. In the controlled ordinary slice, all 3 tested models favor the latent frontier with a 2-point-for-point matched cost accuracy gap over the strongest runner-up. GSM8K Platinum shows the same pattern with a 1.9-point gap. That is the result most directly supporting Hong.
Did the surface and compute views lose everywhere?
No. The paper is careful about boundary regimes. When visible plans are made constitutive, the surface family wins. Controlled constitutive has a 2.1-point gap, and Hotbot QA Distractor has a 2.3-point gap. When search dominates, the compute family wins. Controlled search dominant has a 3.2-point gap, and MATH style reasoning has a 3.4-point gap.
What evidence says the latent state is doing causal work, not just correlating with success?
The mediator tests look for qualified latent signals. In controlled ordinary tasks, ablating the qualified latent signal hurts by 9.4 points. Hatching it helps by 7.0 points. and preserving the latent signal while corrupting surfaced X beats the reverse contrast by 5.6 points.
Does that same mediator pattern transfer outside the control tier?
The naturalistic ordinary task shows the same direction. On GSM 8K Platinum, the early latent readout is 0.70 AUC. Ablating the qualified latent signal costs 8.6 points. Hatching it recovers 6.3 points. And the latent versus surface contrast is plus 4.9 points. That is why the paper treats Hone as the best default, not as a universal law.
What should a viewer take away from all of this?
The takeaway is not that chain of thought is useless, and not that compute budget is irrelevant. The takeaway is that those explanations must be separated. For ordinary reasoning regimes, for tasks where visible traces are binding, H2 can be locally right. For search-heavy tasks, H0 can be locally right.
So future reasoning evaluations need to ask what changed, not just whether accuracy went up.
Exactly. If we want to understand model reasoning, we need experiments that separate visible traces, latent trajectories, and serial compute. That wraps up this paper workflow.